Alright, let's have another example of Gaussian elimination through matrices. So we have a more complicated system here that we have to solve. So the first one is we have to rewrite this into an augmented matrix. So let's do so. There you go. So this is x sub 2, and as you notice we have x sub 1, so that means the x sub 1 of this equation, the coefficient of that is 0. Then this is 1, this is 1 again, this is negative 2, and this is negative 3. Oops, I think I need to write this even longer. So there you go. Alright, and then now I have my 1, x sub 2, this is 2, x sub 3 is negative 1. There's no x sub 4, so I'm going to write it as 0, then 2. The next one, I have 2, I have 4, I have 1, I have negative 3, and I have negative 2. Finally, I have 1, negative 4, negative 7, negative 1, and negative 19. So now, we would have to use our elementary row operations to turn this into row echelon form. So, you can actually start in whichever form you like as long as we strictly follow the operations. And remember, our goal is to write this into row echelon form, which would mean that each of the leading terms, which most probably be this term, let me box it in red, this term, which is already 1, and this term, will all be leading ones, and at the same time, these terms, or these entries rather, not terms, but entries, will become zeros. So, let's start with the first one. Can we turn this 0 into 1 already? Do you see an easy way to do that? So as you can see, this is already 1 and this is also 1. But since this is nearer, I'll just choose to interchange row 1 and row 2. So I will have to interchange row 1 and row 2. So therefore, going to start now writing row 2 as my new row 1. So that's 1, 2, negative 1, 0, 2. Then my new row 2 is 0, 1, 1, negative 2, negative 3. And then, I'm just going to copy the next two rows, 2, 4, 1, negative 3, negative 2, and then 1, negative 4, negative 7, negative 1, negative 19. Now, luckily, one other reason that I interchange rows 1 and 2 is that this becomes 0 already. So all I need to operate on is rows 3 and 4. And actually, you can perform row operations simultaneously. But make sure that we would easily analyze and remember what we are doing. So, in this case, how do we now turn our 2 and 1 to 0 provided that we have a leading one here already? So if you would remember, to have 0 from 2, we can add a negative 2. And given a 1, we can multiply negative 2 to it. That is similar as well when we have actually 1. We can have from 1 to 0, we can add negative 1. Or we can subtract 1 minus 1 to 0. And we're going to take note of these in our operation. So that would mean that to operate on row 3, I'm going to write it here, row 3, we're going to have negative 2 times row 1 plus row 3. While for row 4, I'm going to change color, I'm going to make it green, our row 4, that would mean that I can just subtract row 1 and row 4. So that's row 1 minus row 4. And I can perform these two at the same time on one matrix. Anyway, they are both elementary row operations and I can still get an equivalent matrix. So first, let's write the first two rows that will not be affected by the operation. That's 1, 2, negative 1, 0, 2. and 0, 1, 1, negative 2, negative 3. So therefore now for my row 3, oops, wait a moment. There you go. I rewrote it in black so that it's easier to see what happens to rows 3 and 4. So let's now have row 3. Negative 2 times 1 is negative 2 plus 2, that is 0, and the rest will follow. Negative 2 times 2. Negative 2 times 2 is negative 4 plus positive 4, that is 0. Negative 2 times negative 1 is positive 2 plus 1, that is 3. There you go. Negative 2 times 0 is 0 plus negative 3 is negative 3. Negative 2 times 2 is negative 4 plus negative 2 is negative 6. Similarly, we'll just have row 1 minus row 4. So 1 minus 1 is 0. 2 minus negative 4 is 6. Negative 1 minus negative 7 is also 6. So let's write it here. 0 minus negative 1 is 1. 2 minus negative 19 is positive 21. So there you go. So now we have the first column with the leading one and all zeros. Here in the second column, we just need to change this one to 0 as well. So I'm not going to do any other operation with it because this is just the only thing I need to change. This is 0, so I don't need to do anything that much. So let me just change color. Again, my row 4 would be, now to change this to 0 from 1, I'm going to use this leading one here. I'm going to use the same pattern that we would have here. So that means I'm going to have negative 6 times row 2 plus row 4, because negative 6 times 1 is negative 6 plus 6, and that gives me 0, which I need. So I'm going to do that. But first, I'm going to copy the first 3 rows because I will not be touching them. 0, 0, 3, negative 3, negative 6, and then finally I would now have row 4. So negative 6 times 0 plus 0, that is 0. Negative 6 times 1 is negative 6 plus 6 is also 0. Then I would have negative 6 times 1 is negative 6 plus 6 is 0 again. Negative 6 times negative 2 is positive 12 plus 1 is positive 13. Negative 6 times negative 3 is positive 18 plus 21 is positive 39. Now, as you can see, we can turn, or we have to turn rather, this 3. Oops. There, we're going to use color black. We're going to turn this to 1. And we can also turn this to 1 already, because as you can see, these are the last leadings that we need to turn into 1. So I can have row 3 to be multiplied to 1/3, because 1/3 times 3 is 1. So 1/3 of row 3, while I will have row 4. Let me change color to blue once again. Therefore, I will have row 4 would be 1 over 13 times row 4, because 1 over 13 times 13 makes it 1. So first, let's rewrite the first 2 rows that will not be affected. 0, 1, 1, negative 2, negative 3. Then, let's perform the operation. The first 2 entries of the third row will be zeros. 1/3 times 3 is 1. 1/3 times negative 3 is negative 1. 1/3 times negative 6 is negative 2. Oops, I did not change that. Wait a moment. There you go. Now consistent. And then finally, I have 0, 0, 0, because they're all zeros. 1 over 13 times 13 is 1. 1 over 13 times 39 is 3. And now, as you might have observed, we already have our leading ones here, which would also include this one, There you go. And this is already in row echelon form. So therefore, once we rewrite this equation, let's rewrite this equation here. Now going to have, now going to have, from the first row, I'll have x sub 1 plus 2x sub 2 minus x sub 3 equals 2. From the second row, I will have x sub 2 plus x sub 3 minus 2x sub 4 equals negative 3. Then I will have x sub 3 minus x sub 4 equals negative 2. Then I will have x sub 4 equals 3 from the last row. Hence, all I need to do now is substitute. So therefore, if I'm going to substitute here, I will have x sub 3 minus 3 equals negative 2. That will give me an x sub 3 equals 1. Then substitute these values again to this one. I will have x sub 2 plus 1 minus 2 times 3 equals negative 3. This we're going to give me an x sub 2 value of 2. And finally, I will have my x sub 1 as x sub 1 plus 2 times 2 minus my x sub 3 of 1, which is going to give me negative 1. So therefore, the solution to the original system, which is this one, are as follows. There you go. X sub 1 equals negative 1, x sub 2 equals 2, x sub 3 equals 1, and x sub 4 equals 3.